Hello, guys. Welcome on Unique Concepts of Physics. And in this video, I will be demonstrating that how Faraday and Naumann concluded the third law of Faraday and how they proved that the EMF induced in a conductor is equal to minus d phi by dt. So for that, they used a arrangement in which there was a circuit containing a cell of some EMF, and the two copper strips were attached with that cell, and a rod AB was sliding on those two copper strips, and the length of the rod was L. Now, this complete resistance of this circuit is R, and therefore the cell will flow some current in this circuit. Now we can say that the work done by the cell will be E into I into dt, where E into I is the power delivered by the cell and power into dt is the small work done by the cell. Now let's suppose during the time dt, the rod has been displaced by a distance of dx. Now which force is displacing this rod? You can see that if I current is flowing through the rod from A to B, then there would be some magnetic force acting on this rod, because there is a magnetic field present in this region which is pointing in the downward direction. Okay, so in this downward magnetic field, if this rod is carrying current, then some magnetic force would be acting on this rod, and the direction of this magnetic force can be predicted by Fleming's left hand rule. So by using the Fleming's left hand rule and by pointing the first finger of your left hand in the downward direction, in the direction of magnetic field, and the second finger is in the direction of current, which is from A to B, and the thumb will point towards the direction of force. So by using this Fleming's left hand rule, you can use this rule right now, and you can see that the direction of the force would be towards right hand side. The magnitude of this force, the formula of this force is in fact I L cross B, and the length of the rod and the magnetic field are perpendicular to each other. Therefore the magnitude of the force can directly be written as I L into B. The work done by this force in moving the rod by a distance dx would be F dx, and dw dash would be equal to ILB into dx. Okay, and the third thing, as some current is flowing in this circuit, and this circuit also have some resistance for the current, so there would be some heat which would be generated in the circuit, and the power lost in the circuit due to heat would be I square R, and therefore the heat lost power is dH by dt, and it is equal to I square R. Now dH will be equal to I square R dt. So we can write down the equation that the work done by the cell is utilized in the work done in moving the rod, as well as some heat generated. So work done by the cell is E into I into dt. The work done in moving the rod will be ILB dx, as well as the heat generated would be I square R dt. Now cancelling this I, E dt is equal to L into B into dx plus I R dt. Now you can see that this L into B is the change in area dA of this rod, and dA, B into dA is the change in flux. So E dt is equal to, this is d phi plus I R dt. Now I am solving it for I. So I will be equal to E minus d phi by dt divided by R. Now you can see in this equation that this is the EMF of the cell and this is some other EMF generated, which is opposing the EMF of the cell. You can see that this negative sign shows that this EMF is opposing the EMF of the cell. So if this EMF is E, then it is equal to minus d phi by dt. Now what does the EMF of the cell is doing? That this cell's EMF is moving the rod towards right hand side, and this induced EMF is opposing the cell's EMF. Therefore we can conclude that this induced EMF is opposing the motion of the rod, which is towards the right hand side, and in fact this EMF is generated by the motion of the rod only. So this induced EMF, which is generated by this motion, is opposing the cause of its induction, and this negative sign shows that this EMF also opposes the rate of change of flux d phi by dt. So this was the proof of analytical proof of the Faraday's third law, and Faraday and Naumann used this apparatus or this arrangement to prove this third law. Thank you.